Hey everyone, I'm Said and welcome back. Today we're living up. We already covered the basic of arcsine and arctangent integrals. So in this video we're diving straight into some challenging high-level problems. So if you're new here, make sure to subscribe. Now let's get started. Number 1. The integral of 1 over x squared plus 4x plus 13 dx. This one looks a bit different because we have a quadratic in the denominator. The secret here is completing the square. First, let's rewrite the denominator. We have x squared plus 4x plus 13 equals x squared plus 4x plus 4 plus 9. So x squared plus 4x plus 4 equals x plus 2 squared plus 9, or x plus 2 squared plus 3 squared, right? Now our integral becomes the integral of 1 over x plus 2 squared plus 3 squared dx. This perfectly matches our arctangent formula, means the integral of 1 over a squared plus u squared du equals 1 over a arctangent u over a plus c. So in this problem, u is x plus 2. X plus 2 is u, so if we take the derivative of both sides, we have du equals dx. So we have the integral of 1 over x plus 2 is u squared plus 3 squared du is dx. So we have 1 over a is 3, arctangent of u over a, u is x plus 2 over 3 plus c. Number 2, the integral of 1 over the square root of 5 minus 4x minus x squared dx. This is a tough one. Again, we need to complete the square inside the square root. So we have 5 minus 4x minus x squared equals 5 minus x squared plus 4x. So to complete the square, we add and subtract 4. So we have 5 minus x squared plus 4x plus 4 minus 4. Right? So we have 5 minus, this expression is x plus 2 whole squared, and negative times negative is positive 4. Positive 4, right? So we have 5 plus 4 is 9 minus x plus 2 whole squared, or 3 squared minus x plus 2 whole squared. So our integral becomes the integral of 1 over the square root of 3 squared minus x plus 2 whole squared dx. This is our arcsine formula, because the integral of the square root of a squared minus u squared du equals arcsine of u over a plus c. So in this problem, a is 3 and u is x plus 2. So we have x plus 2 is u, and if we take the derivative of both sides, we have du equals dx, right? So our integral is the integral of 1 over the square root of 3 squared minus u squared du equals arc sine of u over 3 plus c, or arc sine of u is x plus 2, x plus 2 over 3 plus c. Number 3, the integral of x over the square root of 1 minus x to the power of 4 dx. Common mistake alert, don't just use the arcsine formula immediately because of that x in the numerator. We need a clever u substitution. Let u is x squared. So if we take the derivative of both sides, we have du equals 2x dx, which means x dx equals 1/2 du. So we have the integral of x dx is 1/2 du, 1/2 du over the square root of 1 minus x to the power of 4. So we have u is x squared, so x to the power of 4 is u squared. So we have 1/2 the integral of du over the square root of 1 minus u squared. Now it's just the standard arcsine formula, means equals 1/2 arc sine of u plus c, or 1/2 arc sine of u is x squared plus c. The integral of e to the x over 1 plus e to the 2x dx. This looks intimidating because of the exponentials, but it's actually an arctangent problem in disguise. Notice that e to the 2x equals e to the x whole squared, right? So let's use substitution. Let u equals e to the x. So if we take the derivative of both sides, we have du equals e to the x dx. So our integral becomes e to the x dx equals du over 1 plus e to the 2x equals u squared. So this is the classic arctangent form. So we have arctangent of u plus c, or arctangent of u is e to the x plus c, right? Plus c. So don't let the exponentials scare you. Once you find the right substitution, it's a standard formula. The integral of 1 over x times 1 plus ln of x squared dx. It looks complex, but look at the components. We see an x in the denominator and natural log function. So let's use substitution. Let u equals ln of x. So if we take the derivative of both sides, we have du equals 1 over x dx. So look at our integral. The integral of 1 over x dx is du, right? So du over 1 plus ln of x is u. So ln of x squared is u squared. And this integral is arctangent of u plus c. Or the final answer is arctangent of u is ln of x plus c.